Hello and welcome. I'm Bill Wake. We're starting a new project this year. It's going to be some sort of testing framework. I think we're a bit in the exploratory stages of it, but I've got some work done and some ideas for things to try, and we'll just see what happens. All right. Let's see. So some things that we may run across. One is definitely going to be generic types. We'll use that to make our test framework work with any user type or many of them. We're going to talk about parameterized tests. That's the piece I've kind of got done. I want to look into combinatorial tests or generated tests, sometimes property-based tests, sort of different ways of quickly generating tests that cover a broad area. We'll look at reflection. We'll look at the notion of domain-specific languages, and I think we'll probably end up using either one or both of property wrappers, which is like we've seen that with Swift views, like observed object and at state and things like that. And then result builders. And again, we've seen that in Swift UI. It's how they build views, but basically it provides a way to make domain languages, kind of giving you a level of control, one level above syntax, but you're not as intense as the compiler, but you've still got access to a bunch of information. And we'll see if we can make use of that. I don't know. It's all fuzzy right now. That's okay. Some resources. We've got a little information on result builders. I saved a couple links there just so we have for reference. Now we have a starting point, and this is a little test framework I made. I don't remember which application it was, but I wanted to do some combinatorial type tests. And so the idea is you've got some inputs and outputs, and you're going to initialize each example. And notice in the middle there, line equals line number, pound line. We're going to capture the line number of the test case, basically. And so we're storing, this is the input I'm giving you, this is the expected output, here's an optional message string, and here's the line I'm on. And you can get back the message string, the line number in the message string in that message operator or function. All right. And then there's a function check test cases. And what you do is you pass in a parameterized assertion and a bunch of tests, and then you run the assertion code over each test. So you're going to have an array of it like this. I use P for the test case there. I'm still working through the names, obviously. But input is -1, 1, so it's a pair. We can use any type because we were generic. Output is expected to be quote 0, and then a message 0, and so on. And then 3, 0 gets output 3, -2, 1. So this is actually an addition program, and we want to add the two numbers and convert it to a string. So I'm making a demo, which is my object that's going to do it. And then I'm going to give it string of sum, input.0, input.1, coming from that parameterized thing, and make my assertion. So after the for each, that's a closure that is representing all the assertions you want to make given P, which is the parameterized input. Let's see, next. John Reed used this or took a look at it and gave me some advice. One is pushing, let's see, I think we flipped so the input array comes first, and then the closure comes last. Okay. And actually we don't need that extra parentheses around it, but that's okay. Rename things to test case, and provided a static assertion that does the for each, so we can just call that assert on it. And we'll see how to incorporate this stuff or what we want to do. I don't know. I was trying for some sort of very lightweight naming to let it kind of fade away. So I don't know. Test case is a little wordy, but we'll see. And then I picked some color scheme just to get us going. Okay. All right. What I've done here is I've created this as a library, and it's got nothing. Okay. So my thought is for a first stage, probably today's focus anyway, I want to get this code in place. Okay, let's create an example. I don't know. I'm not quite sure what our library is supposed to be here, but let's see. This is, I think it's called example. Well, okay. We're back to not doing that. Whoops. This is why I'm supposed to let the IDE name it. Okay. Struct example. All right, that gives us something. And what else do we have? This is just kind of a bare function right now. Okay. And then I think, whoa. Yes, replace with space. Thank you. Can I put a test case? I think that's because I called it example up here. Why I can't get rid of these, I don't know. Like, thanks, Keynote. Okay, example. Reference to generic type example requires arguments. Oh, I see. Will you do it for me? No, we don't want to do that. Let's make this input, output. Okay. I still got not breaking spaces. Expected braces in body. I don't know if these spaces may be throwing it off more than anything. Expected brace in body of. Maybe I'm doing this wrong. Always a possibility, eh? Expected. Oh, yeah, that's true. Okay, so let's try and incorporate this. Let's go ahead and make a test for it. Rearranged on me a little. Test case class. All right. Let's make this example tests. And we don't need most of this. I guess we'll keep the example. Reformat, take this one out. Okay. And an example. We have more of those. Right. Excuse me. Yeah, that's all fine. P is now called example. Okay, and we don't have a demo class yet. All right, class demo. And demo needs string of sum. And it's going to take A of int and B of int, return a string. And let's mess it up. Let's see. Test double import ptest package. That's going to need a better name. All right. Let's just return question marks for now. Okay. What else? Actual string of sum. Oh, I don't want to have to put those. Okay. Okay, so we predict failure. Well, oh, it's building. Okay. Failed line 1, line 22. Okay, so here we're seeing that we get the line number of the test case itself. So that was kind of important to me. Each of these, notice they run in a random order. We don't control that so much. Though that seems weird to me. Maybe it's just a weird artifact of the way it keeps track of results. Because we pretty much do run them in order. Okay, but I think individual tests, we don't control the order. Okay, so we've demonstrated our function fails. Let's do something. So let's return, whoops. Let's do math. Is it math.abs? Am I mixing up my Java? A plus B. Absolute value of A plus B. Okay. Right, let's run that again. I expect 2 passes and 1 fail. And this is just demonstrating we can get partial success. Okay, rather than total failure. Okay, since we took the abs, the one that was negative doesn't work. All right, let's take this off. Do the natural. Turn this on. Build succeeded. Did it run? Oh, just control. Command U. Okay, and everything's good. All right. Okay, so now I want to improve things. Okay, so one thing I could do is this. I could call check test cases in here. So check test cases, and then I foolishly put them in the wrong order, But this closure here comes first, and then the array, and then the for each is the code in the function test case, check test cases. Okay, so this should pass just as well as the other one did. All right, and then go back to John's critique, like, hey, it would make sense to put this first, put the test cases and then the assert. Okay, so let's make that change. And I don't know, I wish Swift had a change signature because that'd be handy for this. Okay, so now I've got all right, so I've got the tests first and then the assertion. So let's go flip this to reflect that. So this, we have this notion of a trailing closure in Swift, so we can put it like this, much nicer. All right, and then that closes that. So this should work still. Okay, so let's make this slightly revised version of example tests. Yeah, I'm still working on the naming of things. Example, I don't mind that. I think I credit Brian Merrick in my mind of bringing that word example in pretty solidly to the Agile community. You know, an example would be handy right about now. You know, a little bumper sticker. I think I have it somewhere. Oh. Let's see. This way. It just seemed fitting to put it on my trash can because, like, you make mistakes, you throw it away, and you realize you can get more concrete will be better. All right. This is definitely an improvement. All right. And I think, I don't know if John did it with the trailing closure, but we definitely would use that style here. All right. Now, I guess I'm jumping ahead to, would it be useful to attempt this result builder kind of stuff? Okay, but let's see what's John's other critique. I think, yeah, static function. Did I make that static? I don't. Well, I think let's see if that works. No, static methods must be on a class, right? Yeah. I guess the question would be, I may have to pull up his email, but I think his concern was if, well, leaving a bare function up there is probably not so nice. You know, we're kind of in that global namespace. And so if you made it static, maybe in the, yeah, maybe we can just say check. Like, what if we put it on the struct? I'm never quite sure where to put them, but let's do this. Okay, and then in our example, we're going to have to say example.checkTestCases. We'll work on the words if this works. No. Generic parameter input cannot be inferred, output cannot be inferred. Okay, so let's put it on its own class. know if there's any difference with class and struct for this purpose. Cannot find check cases in scope. Okay, so this is check test cases. Okay, see if that works. All right. Put in class. Put check test cases in class as static method. Okay, it's a little wordier. All right, I think we can rename this to like examples. I don't know if maybe I'm working towards the word examples as my working name for this. Check examples. I mean, that reads okay. Check examples. Here's a bunch of examples. And here's the check. Okay. I'm kind of okay with that. Examples still input, output, then the message and the line number default. Yeah. The thing I resent. Let's rename this EX and just see what happens. I almost want to do EG. Check examples. I'm gonna try it. It's a little weird to name things with a lowercase letter, but I think this might, people may hate it, but I kind of like that. EG, input, output, EG. It's normally a class name is uppercase, and I could do that. Let's try that just to make sure. I mean, maybe that's okay. How's that looking? I don't think that's impossible. Something like exempli gratia. Here's a free example for you. E.g. input is this, output is that. Check examples. I'm kind of there. Okay. Now, all right, that's kind of a major point to me. So change to EG for example names. Whoa, what happened there? Okay, let's cancel that. Let's do some renaming. Let's call this EG2. It's a case issue, I think. Really wish I could leave that automatically checked. Swift. Huh. What have I done? just commit this one. Okay. Before I get too happy, make sure it does work. Okay. Okay, so how can I live with this? How do I feel? Well, I like EG being short and sweet. I liked the lowercase better, but it doesn't conform to the standards. So I'm going to let that go. But I'm okay. All right. Now I'm very limited in use of Git. I don't branch very often and stuff like that. Like the only times are really like for some training things, I'll set the original, do a branch to show one approach and a branch for the second. But day to day, I normally just do everything on the trunk. But I think I want to at least tag this version. I think what we have is worth noting. Okay, so tag this. This is parameterized test with EG. Okay. And I think what we do from here is more experimental. So if I had that much, I would be okay. But I'm wanting more. And I don't know if I can get it or not. It's going to get more complicated. That's the problem. All right. But like what I would like, what if, let's make a copy of this and explore just like what could it be. Now, this more DSL style might be like this, and then I don't need that, and then that. I don't even know if I need that closure. Too. So my version of this so if you said check, then like the first argument is going to be an array of stuff. And if it's not an array, we're going to complain. And then the second argument is a closure. Now, P, that depends on whether I can capture this. I don't know if I can or not. That with this result builder stuff. So we're branching into something that's way out of my experience level. What did I find? I had some resources. There was a video too. Let's see. It was, let's try WWDC result builder. That's the one. Okay, so let's put that on the link here too. Okay, so what? Maybe I'll make this a new name. Okay, and somewhere in I have a notebook where I took some notes on this. Okay. Now we have. Let me just open a. Let's go back and look at our tune sim. Okay, and let's get to our UI. Content view. So all this stuff in Swift, like HStack and VStack and text and so on, these things are they are result builders, and like they take a trailing closure, and they also allow modifiers. And then the other piece that they use for DSLs is this property wrapper stuff. And I don't remember all the details of what that does, but basically it lets you get another level of indirection somehow, I think, of before and after changes or something like that you can kind of monitor it. Now, I don't know that you can, the piece I'm missing, like if I were doing this with Java, I could make this at state builder. It could be a certain kind of user defined attribute that I could attach to a variable, a class, a function, and so on. There seem to be attributes you can attach, but I don't know if you can define your own. You can define ones that go around variables. That's this property wrapper. Okay, but this sort of style where there's a function, maybe it has some arguments and a trailing closure, that definitely is managed as a result builder. Okay. Now, okay. Right. So what's going on is, in effect, this thing gets access to each statement inside it, and there's another class that knows, like once you've built something, it knows it can pass each of these in as entities to the overall VStack. The other thing is there's a limit of 10 things that you can have in a view. Okay, we got 1, 2, 3, 4, 5, 6, 7. I don't know if I put 8, 9, 10. Should be okay, and then this should get complaining. I think. Maybe I'm off. There are definitely places where you can only have 10 of something, and well, maybe this is not one of them. Okay, but that's a function of this the way the view builder works. It breaks them into separate calls, and then it can kind of control the result of each call, what it does with each result. Okay, I'm not seeing a complaint yet. Well, I'm not seeing much of anything. I guess my computer's a little overloaded. Okay, we'll come back to that. All right, but let's see. Shrink this down. Okay. Oh, there's some errors. Let's see what we got. Unable to type check. Try breaking it up. Yeah, it doesn't like all that stuff. Okay. There's actual complaint here. Yeah, scroll view is not happy. Okay, let me revert this. All right, but that's an explicit. There's somewhere a function with 10 parameters that doesn't like 11. Okay, and the Swift UI package deals with it. Okay, now. All right. Okay, we're in a totally weird, spiky kind of place here, and then we'll come back and deal with it. Okay, so, let me close that. All right, let's make a check 2 and see what we can do with it. All right, so all right, let's try result builder. And I think what I saw was enum, and then this is, let's call it check 2, and it has no cases. So it's not a regular enum. This is just a place to attach stuff. Okay. And then because it's a result builder, let's find some documentation. Let's go with this. I don't know where it's going to open that link. Okay. Let's pull this apart and put it over here. Okay. So let's find result builder. Okay. So what we have is we have methods that take stuff like components and assemble them into bigger components. Okay. I don't quite know how we're going to use this, but okay. But basically, okay, so combine an array of partial results into a single partial result. A result builder must implement this. Okay. Now you can also implement these other things. Optional either array, for loops, expressions, and so on. Okay, final result. There's some distinction. You can have a final result different from the overall type if you want to. Okay. Oh, here's an example. All right, so we got a result builder, a struct array builder, and we know we have to implement build block. Okay, and what it's doing is it's going to take it's taking the array of stuff and joining it. Okay, and I'm not sure what, but it builds an array out of that. Okay, so it returns an array of stuff consistently. Okay, and then you've got these other optionals and ethers and so on. Okay, and build array is very much like build block. Okay, we'll have to build a partial result from an array of partial results, or combine an array of partial results into a single partial result. I don't quite know what the difference is there. But the goal, let's see, the goal here, well, we want build block anyway. Build block is the one function we have to have. And then components, can I tell? components are examples as a list of examples, and we're going to turn that into, I don't know what. Okay. And it's going to turn into components, and has to turn into build, has to return component. Expected an attribute name. Oh, I got two ads. Okay. Result will return 2. Reference type car seconds. Okay. Well, we're gonna have to straighten that out later. Okay. What am I returning? Well, it's not an example. I don't know if I can do this here. Input, output. Okay. Oh. I think I'm saying if you have a list of these, how is that going to work? Well, it compiles. Okay. So that's something. Okay. So what I'm saying is check 2 is going to take a list of examples, and it's going to turn it into an array for us. Okay, so I think what that's saying is this can go away. And I think these commas go away. It's no acceptable initialization. Int to string. And I'm hoping we can get rid of this eventually. Cannot be constructed because it has no initializers. Okay. Check 2. Let's look at this example again. They did it in a struct. And they said what component is. Okay, so I should be able to make one. Okay. Extra trailing closure. That is true. Okay. But I think that's kind of... That's kind of good. Now, I don't know. I feel like I was able to, let's say, assert is this. Requires a label. Okay. Assert that. And I don't need it if I'm making this. Now, can I? Let's build. Build failed. Ugh. It's like it's trying to attach this to EG, and it doesn't like that. What if we put it first? And I mean, I guess we'll get it working and then worry about aesthetics of it. But now I'm saying this goes up here. Okay, extra trailing closure passed. Unable to infer type of closure. Current context. Can I do this? It's not going to work. I don't think it's going to like that any better. Yeah. Can I say? The type of P is... Well, let's... put both these up. Okay, and I don't know. The type of P is this. I don't even know if I'm allowed to say that here. Cannot find P in scope. Types, expressions, statements, declarations. I don't know if I get an example there. I got generics. I don't need where. No. function type. Let's look for closure. Type of function, okay. Well, let's do that. I'm looking for an example of calling one of these where we specify the type in the closure. And I'm not seeing it. No, that's different. Okay, let's look for Swift closure examples. Actually, let's try Swift closure specify type. Okay, takes us back here again, but that's okay. Closure parameters. Name of string. Oh, parenthesized. Okay. That. Extra tailored closure passed. Extra trailing closure passed in call. Well, he's not a trailing closure. Ugh. He's this closure. Where's your closing parend? Brace. Okay, and what's your complaint here? EG has no member input. That's not really true. It absolutely does have a member input. EG int string goes to nothing. Well, a function. Oh, he's not. He's an example. He's not a function of an example. Okay. EG int string. Yeah. Okay, now we still got an extra trailing closure. Passed in call. Well, he's not a trailing closure. He is the closure. Assert is a function from an example to a void value. Okay, so he just does something. He doesn't return anything. Extra trailing closure passed. I don't know if a type would help. You can tell I'm starting to bury myself in this, but okay, let's get back to result builder. Result transformations. Okay, so if a builder has a build expression, each expression becomes a call to that method. This transformation is always first. So the expressions are equivalent. Okay. So I almost think array var. The method. So if you make the tag array builder and then you pass in this thing, it's going to create a number that is the result of this build number thing, build expression thing. Now I don't know what I've got here. Those are not blocks that I'm doing down there. Let's see. Build expression returns expressions. Is int. Okay. Maybe I need to start simpler. This is funny to me because these are what are they? They are EGs. Okay, and so they seem closer to expressions at that point. So build expression is going to take these elements and return them as an array because components are arrays. So I can have expression is int. Okay, let's do something like that. Okay, type alias expression equals EG. And then component, see if this will straighten anything out for me, equals, I don't know, array, a pair of, well, let's just make it an array of EGs for now. Maybe that would be a good first goal. And maybe I shouldn't be fooling around with generics and these at the same time until I get one thing working. Okay, so now if you give it an assert, oh, I didn't put the name. All right, let's take that out for a minute. Okay, what's this do to it? Does it help? I want to get rid of this trailing closure argument. Okay, what if I put it back in? Assert this with this body. Argument passed to call that takes no arguments. Remove this. Build block assert takes in a function, a closure, and a list of components. think spaces matter here. Assertion passed to call but takes no arguments. Okay, well, it doesn't like that change, so let's... Why are you not highlighting like you're supposed to? Because you're confused. Can I find P? If I... Oh, I went too far. Back to my trailing closure. Past any call. I'm saying check 2 takes this build block. Now I'm kind of interpreting build block to say I can create whatever I want for arguments, and maybe that's not true. Build block combines an array of partial results into a single partial result. Maybe I gotta... What if I make a build expression, and it is a component of e.g. input output, and it returns Let's make another type alias. Type alias assertion equals this. Is that legal? No. So what I'm thinking is maybe we produce a pair that is an assertion function and a list of expressions. And I don't know. Example with input output produces a function and it's producing an ordered pair of a function maybe one more paren order pair of a function. Wait a minute. Input output goes to nothing. That's that. That's what it doesn't like. Okay, I'm gonna make another class. Ugh. Let's call it component. We'll work it out later. Ugh. It's got var. Well, maybe I don't need. Let's do it. Let assert be e.g. of input output goes to void. Okay, and examples require parentheses is of type eg, array of eg. Okay, one more level of parentheses makes you happy. Input output. Okay. Now let's make this a better name. This is let's call it a test. Okay. So this thing is going to take a component, well, let's really call it an expression, and it's going to produce a test. Reference to generic. Yes, test is going to have to be input output as well. Oh, yeah. Okay. Given this, what will we return? Well, I think we're going to return what am I thinking? I'm thinking somehow I'm going to take these pairs, take these tests that represent both these and somehow combine them. Test with this is take something and does nothing with it. And I could maybe make them optional, but I'll just do that. Expression. Okay. Now, yeah, okay, fine. Assert nothing and expressions. Okay. Now, is this is getting, I don't know, maybe this does go outside. Closure, past, and call. Let's comment this out for a minute. Can I get this part working? No. Well, maybe. My notes give me any clue. So somehow I should be able to say at check too. But I don't know where I'm saying it. Okay. This. I don't know. Can I say it up here? And then just put these as arguments. Okay, let's simplify. Reference to generic type requires arguments. Okay. Int, and string. Cannot convert array of these to a void. So array of these is maybe I need a simpler example. Value of array of these to a specified type void. Is that this function is producing an array? Is that what's really going on here? Array of int, e.g. of int string. Cannot convert value of test to e.g. and so is this producing test? No. Cannot convert value of e.g. int string arrays to type test. Where's it going to put that? Yeah, no. Oh, maybe is that there? That's the body of the function. Cannot convert value of test int string to e.g. int string. Missing parameter for assert. In call. Insert assert. Is that this? I don't see how. Cannot find P. Do. something's grossly messed up. Okay, let's take this out. Let's take this out of here. What if I just give it components? Let's take out the assertion completely. Test string cannot convert e.g. int string to type. Is that? No. Cannot convert value of test int string to respect to type e.g. int. So this thing, the test value must be coming from build expression, because that's the only one who references that. So each of these expressions is getting called by build expression, and it yields a test input. So what if this did that and says, you give me a bunch of test inputs and I will give you an array of EGs. Now, I don't think you can do that. Yeah. Okay. If I did component.map $0.examples, and what is he? He's, I guess maybe this is .flat map. Okay, so if I map each one of these to its examples, somewhere I need to do a flat map. Okay, if I map each one to its first. Okay, let's take this out. Okay, so build block says, give me a test, and I will convert it. Yeah, I think I still want to do this somehow. Okay, so if I map it to examples, then I've got a list of arrays. And maybe I can do a flat map $0. Will that give me the right type? Looks like it. Okay, so that takes all those arrays and then combines their elements, so we get a list of EGs. Okay, so we're throwing away the assert function, which we never put anything in there, so that's okay-ish. Now over here, what's going on? This input value, let's do a build again. Build succeeded. Okay. So now I've converted this array of stuff is an array of these. And build block is happy to do it. Okay, but I'm returning the whole thing at this point, so that's kind of unfortunate. And I would really like to infer the types, and we're not dealing with that at all yet. Maybe I can't. Okay, I don't want to return that. I want it to be a void result, but right now it's calling build expression on each EG line because it sees an expression. Okay, and then it calls build block on the result. I know I'm overcomplicating things. All right, but now can I add that function back in? Assert is of type it's this thing. Assert goes EG of input output. Sorry, let's get this straight. EG of input output. I think I want another parent here. Oops. Okay, so this is a argument goes to void and close that parent. Okay. String, what are you? Right. Okay. Let me do some formatting. Build block. There's no arrow here. I don't know what I did. Build block takes components of test, input, output, whatever's, and an assertion of this. Flat map $0, and it returns. I think it returns nothing. Okay. Let examples equal, take the flat map of this, and then we call assert well, then we call check, I think. Examples, which are currently tests, but we'll get past that. And assert. Now the problem is going to be check examples doesn't like getting a bunch of tests back, which I think that's overkill anyway. Why are you happy? I don't think this should be right. Examples once EG array of EGs, and it's getting an array of tests, I think. Oh, he's an array of EGs. Oh, we flattened them. Okay. From the tests. Okay, so that part's okay. Now what's up here? Missing an argument for assert. And components. I want this to be a no argument. I don't want to mention those. See, I don't think I can put them in here. All right, let's uncomment this. I think he's still not quite right. I think he's going to attach it to the EG instead of preference calling by multiple new lines. If I did this, would I get rid of a message? Yeah, get rid of one, but not the real thing. Okay. I don't know if I can. So maybe I need to do something more like this. That's like examples, and then give a bunch of examples, and then check. I'll use a different variation, but I'm going to put the trailing closure there. Let's see if we can make that work. And then we'll see what we can do with it. Okay. I feel like I'm kind of on the verge of understanding things, but I don't like having to do this. But if this all worked because of it, maybe that's all right. Okay. Let's take a break, a couple minutes, maybe 3 minutes, and we'll come back and see if we can make this thing, make this work. Maybe for each. I don't know. All right. See you in about 3 minutes. Okay, welcome back. I'm going to, this is one of those links that I had saved, Result Builder's Advanced Operations. So let's work through this example. Maybe I'll understand what I'm doing a little better, and we'll see what happens. Okay, so they're starting off with the sort of old school way. They're going to create a protocol drawable, and then they're going to make line, text, space, and so on, implement the protocol, meaning they'll have a draw method. Okay, and line draws, well, I guess it draws whatever elements you give it, and text puts the string out there, and space puts a space, and stars repeats stars, and all caps uppercases it. Okay, and then you can build a drawing like this, stars length 3, text hello, space. You put all that in a big array and do it. Okay, but like, what if we could get rid of this? All those caps. Okay, use world when it's nil. Yeah, okay. All right, so they create a result builder, drawing builder, give it build block, which is the required one. You give me a bunch of drawables, I'll produce a drawable, which is a line with those components. Remember, line is not an array of dashes, it's a bunch of stuff in a line. And then build either, let's use if blocks. I don't quite understand how that can distinguish these. That's a little weird to me. Oh, their keywords are different. Okay. All right. So drawing builder, we apply it to a function's parameter. Drawing builder content produces drawable, just returns it. Okay, so content of nothing to drawable returns the drawable. Caps applied to content produces a drawable with that content in it. Okay, here's make greeting. Draw is now takes a closure and accepts these entities, and then caps takes a closure and does that. Okay, so maybe we're not marking the right thing. And then the if takes this into account and calls the first and second, so that's okay. If you want loops, add build array, and then you can write a for loop and it'll call this with that. Okay, so I think what I'm not doing is I'm not doing the equivalent of this. The result builder we build gives us this declaration that lets us create these things that take closures that will be the stuff. Okay. All right, now relating that here, like check 2 is in the wrong place. I want check 2 to be maybe I want examples in my version here. Okay, so let's make struct examples. Oh, maybe it should be function examples. Let's make a function examples. Takes our type thing, check 2, and then it's going to take content of, well, drawables, the protocol. Drawable. I don't know. Okay. Content. I'm getting draw twice here. Function draw. Okay, I guess that's nothing to do with the protocol one. Well, let's make this EG of input, output. Okay, so function examples, well, yes, it has to have a body. And it should produce something. Produces the thing. Well, let's produce EG. That seems silly, doesn't it? Content, nothing goes to EG. Nothing goes to that, produces that. Requires, yes. If I can get all the generics on this side of things, then I'm happy. Okay. Missing return in global function. Yes. So, and all they do is return their stuff. Okay, so this is, I guess that's my closure producing this. Okay, now examples in scope. Oh, now that one is there. Okay. Now, let's input output. It's going to take a check to input output, and then the check to basically is producing EGs from a list of stuff. Let's define a builder for the function. Golly. Let's see what's going on over here again. All right, so caps produces a drawable. All caps where content is the list of drawables. All caps. I don't know. These all want to produce the same thing, and these don't. So that's what's throwing me off here. Checking, I think, wants to produce I think he wants to produce, I think his content is going to be produces our function. Can we do that up here? Tried this once already. Type alias assert of input output equals, it's going to take a case and produce nothing. Produces nothing. No, it produces an assert. Okay, what does that do? Oh dear. Check 2 can only be applied to a function of parameter of function type. Okay, expected complete argument list. Input, output, input, output, input, output. Those all look okay. This one's not happy though. Result builder check 2 can only be applied to a parameter of function type. Now that makes me think check 2 is not the right thing. Where's check 2? Check 2 is producing these EGs. Okay, let's make a check 3. Yay. Okay, check 3 takes input and output. I don't know what its build block is going to do, but its build expression should take an assert of input output and produce an assert of input output. And then the body of that is just expression, I think. And the build block I don't know what this thing should be doing. Well, components are going to be assertions. I don't think I even need a bunch of these. I think I can just do that. Block. Expected declaration. Body and function. Returns void. Well, maybe it returns an assert. Input, output. I'm just bubbling it through. And we'll just return component. Okay, so check 2. This is now check 3. Burying myself, I know. Okay. Expected bracket to complete generic. Result builder can only be applied to a parameter of function type. Check 3 can only be applied to a parameter of function type. Well, that is that, I think. Oh, got a space in there. Is that? Okay, this side looks okay. All right, so now cannot find checking in scope. Okay, everything's unhappy now. Cannot convert EG event string to nothing to closure type EG event int string. Examples. I don't know. Let's try this one. Cannot convert value of EG int string goes to nothing to closure result type empty. Right, that's not quite right. Okay, so check 3. Oh, I got the wrong one here. This is a check 2. Which is overly complicated, but okay. Let's do another build, see if anything changes. Using parameter for assert and call. Cannot convert argument type empty to closure result type EG. Let's take out this assert on check 2. Check 2. Take out this. Okay, check examples. Doesn't need assert anymore. Well, he's supposed to return void. Check 2. Now I want him to return an array of tests. Array of EG input, output, and his type is EG. Stripping out some of that other stuff. So EG has no member examples, right? So EG is, well, let's try array of components. Okay, so now build block says you're going to give me a bunch of EGs, and I'm going to turn them into an array of EGs. Fair enough. And then expressions, I think, again, EG input should become EG output. That seems redundant. We'll return expression. sorry, check 2. Don't know if I'm getting better or not. All right, so check 2 is dealing with the examples. He says, give me a block with a bunch of examples, and I'll turn it into an array of examples. Give me just an example, and I'll just return it. I don't know if this is redundant. Okay. Check 3 says, give me an assertion, and I'll return it. And same thing for an expression. Again, I think that may be redundant, but until it's working. Okay, cannot convert value of type empty to closure result type, e.g. and string. Whoops. Okay, let's rebuild. Now this I don't think belongs on here anymore. Cannot convert value of array of EGs to closure type EG. What do you say? Cannot convert EG function to closure result type this. Cannot convert value of type the thing to expected argument type EG. I almost think this one. I think maybe this is hurting us. This is the check 3 expression. Because I want this to be a closure going to this thing. And then somewhere cannot convert value array to closure type EG. Who is doing that? Let's look at check 2. I think this feels redundant to me now because he's being passed in a bunch of EGs, so I don't think we have to do the expression stuff to it. And I might just do a rebuild. Cannot convert array to closure type EG event. Array EG to closure type EG event. And this component is one assertion function. I feel like I'm close, but just not getting over something here. Okay, so maybe let's focus on this one first. Cannot convert value of type array of EGs to a closure type EG. Who is asking for closure type EG? All right, let's look at examples. Where's examples? Examples. Okay. Takes a check 2, which is a void, goes to EG input. Now that seems... I think maybe this should be producing an array of... So check 2, given a bunch of components, produces an array. I think maybe this needs to be an array here. So you give me a bunch of that. Okay. Input, output. It's saying this turns an array of stuff. Okay, now we're getting somewhere, maybe. Content. Examples unused. Okay. So we built this is, well, you give me stuff and I produce an array of input outputs and nobody's doing anything with it. Can I do that? Then cases should be array of input outputs. Okay. And no type had to be specified to get that part. That's good. All right. Now, this thing, cannot convert value of e.g. int string goes to nothing to closure result type that. And then the assert equals cannot convert value of type nothing to expected type example goes to nothing. So I'm trying to pass a closure, and is there a build closure? Where's that other? Let's get that other link out. Oh, I don't even have a to-do going, do I? Other link. This one. Build block. I don't need to type erase. Okay. Build block. So I feel like if I said components, I still want to pass in my closure. What's going on? All right. Well, we're closing in. Okay. Cannot convert e.g. event string goes to nothing. Okay. To closure result type empty. Now, that's sort of this value, e.g. goes to nothing. That is actually the value of this closure. It doesn't produce a result. I almost wonder if it's breaking up the contents of the closure and trying to apply individual and result builder stuff to the steps, if that's why this one's being. because it's the whole closure is this type, e.g. int goes to nothing because it produces nothing. Cannot convert e.g. to result type empty. That type empty to closure type. Right, that doesn't take our example. So checking, you give us an assert input output and it produces, I think maybe it produces void. Unexpected. Is that gonna do it? See, I want to assume that the whole thing is going to get called somehow. Like this. Examples of content. We'll see examples again. Examples check to content goes to that. Can I put an assert? Examples of input output. Content is nothing goes to input output, but let's add assert of type assert of input output. All right, and then let's apply assert of content. Is that right? Cannot convert return type empty. Content should be the array of stuff. So we want to call our check dot examples of content and assert. All right, let's go back up to check. He has examples of tests and assert, and he produces nothing. Okay, so I want to say that expression of type empty to return type input output. Okay, this should be empty. Okay, so now I'm saying examples takes, I hope I'm saying this argument is a check 2, which is an array of stuff, and it takes an assertion and then runs the assertion on the example. So that would be more like this. Missing argument for assert. And can I make this optional? Missing argument. to your problem. Closure expression is unused. Second argument for parameter number 2. E.g. event string goes to nothing, which is exactly the type of this. Missing argument. This e.g. int string goes to void. Takes an example of e.g. int with output string, which is this, and then it does something that's void. I mean, I think this thing is the right type, but I can't convince it. Oh, okay, let's be explicit. No, what can we do? And that is what I really want it to be. Oh dear. Now, I'm going backwards or not. Maybe tomorrow we'll start from scratch and see what we get. All right. I don't see how to get that argument passed in, even though I think the argument is the right type. I think if I did this, component is this, what would that work? Well, it's content. And I can make it optional. Let's do that. Content is optional. Contextual type, insert. Well, I don't see any difference in this. Okay. What's the problem here? Oh, rebuilding helped. Okay. Well, that looks an awful lot like our original, doesn't it? Check examples. It changed brackets to braces, but that's no big deal. Took out some commas. I mean, slightly nicer. Okay, what if examples? I don't have the, what do you call it when you query these functions, right? You make it so you make a function of two arguments to be one of one argument with one argument pre-filled. That's kind of what I want here. All right. So what I'm thinking is it would be nice like I would love to get rid of the brackets completely. Check 2 seems to be applying this. So check 2 is saying, I'll take your argument. It's a void expression, like a list of statements, data declarations. I'll turn it into an array of those things for you. Okay, so I got rid of the commas. Woohoo. And then the result of all that is this array of stuff. Now, what I would like it to be is a function. Okay, let's see. I would like it to be a function that takes an assertion and calls it. Okay. Function my asserter. And it takes this and this examples and assertion. And it produces nothing because it calls it. Is that quite right? I want to do my own currying, so maybe I just want to say, just take the one argument. Okay. And what you should produce is a function that takes an asserter, an assert, and produces void. I guess he's going to have to take that as well. Okay, so here's a function. If you okay, I'm going to bury myself even deeper. My asserter 2 obviously takes input output. Okay, and if you give me nothing, okay, well, that's implicit. Okay, so doing this, you're going to give me a function an assert of type assert, and I'm going to call assert. Where's assert defined? Oh, assert input output. Okay. I'm going to call check.examples. No, I can't call check.examples. Expected return, global function. Okay. Okay, somewhere here. Okay, so this thing, you pass me the check2 content thing, the array of input and outputs, and the assertion function. I want to call well, is that wrong? Maybe I don't need that stuff. Okay, here's examples, and he takes that in the assertion, and it's going to call check examples and do this. Okay, let's build that. And this should work. Now, I don't know. Is that much better than this? I have to put the parens in here to make this thing take its trailing assert. The other way was I could make the examples assign the examples output, gives me the array, and then pass that into this function with my check assert. Check.examples. I don't think that's any better. I don't know. It's a lot of mechanism to cut out swap brackets. Well, swap braces for brackets and drop the commas. If I could get rid of the parens and then just do could I get rid of the parens? I mean, examples is a function. It just couldn't get that working, right? I mean, if it had no parens, it just didn't know what to do with that. Okay, I'm gonna let that sit overnight. I don't think all this mechanism did much for us. Let me tell you the other idea I had. I want to do something like let subject equal arrange and do a bunch of stuff. I'm going to try my Arrange-Act-Assert, and then I could say let actual equal act of a bunch of stuff, and then assert a bunch of stuff. That's none of that is here. Okay. And assert, I'm thinking this is a list of Boolean conditions. Actual dot count equals 1. Actual sub 0 equals X, whatever. I don't know if I can get what I want out of this. I want those assertions. I want this assert object to run the bracketed stuff and check those conditions and listing them as separate conditions, kind of like we did with the examples. That's what I'm thinking of for tomorrow. So we'll see. Well, I think we'll clean up what we have here, but it doesn't look that compelling to me. I think this is probably okay enough and a lot easier to understand from the user side, like how's it really working, but I don't know. We'll see. Pardon me. Let's see. So yeah, we'll pick up there tomorrow. I think I'm still satisfied enough with the parameterized one. We'll see. All right. Thanks for joining today, and catch you again in the future. Bye-bye.